Hi, this is your host Akshay with another video here, and this video is going to focus on electrical energy. Mind you, this is gonna be the last concept of the lesson called electricity. So words in electrical energy, and these words are not new to you because if you have just watched the video related to electric power, it is being clearly mentioned over there that the electrical energy is being consumed in a given electric circuit there. So let me just tell you a few things there once again. That is, when current begins to flow through a conductor, then the resistance of that very conductor opposes the flow of electric current. Electric current has got one option to avail here, and the option is to overcome the resistance. And in order to overcome the resistance, current has to do the work, and in order to do the work, energy is required to be used. So hence we can say that electrical energy is being used in order to overcome the resistance of that very given conductor. So the energy used to overcome the resistance of a conductor does appear in the form of heat energy. So here we are gonna understand what is electrical energy. So remember that the electrical energy consumed, electrical energy consumed in order to do the work. Okay, that is what we have learned in the case of power. If you are having a kind of a fresh memory of electric power, then you will say, yes, we have learned in electric power that electric power is equal to electric energy consumed upon time taken. That how much electrical energy being consumed by an electric appliance in a given time is known as its power. So that same is here. By knowing the electric power, we can drive what is electric energy consumed. So the electric energy consumed depend upon two factors. One is the electric power of that very electric appliance, and the second, the time for which that electric appliance is gonna be used. That will summarize the amount of electric energy consumed by an electric appliance. How much electric energy being consumed depend upon these two factors, and these two factors will make the definition of electrical energy consumed by an electric appliance. So let us just drive a definition for electric energy. Thereafter we will just step on the unit, and finally we are going to take on the commercial unit in which electrical energy is being expressed. So let us have a definition of electrical energy here. I think that you have got the idea, but the electrical energy is all about here, that the electrical energy which is consumed by an electric appliance there with respect to time taken, okay, that's gonna be known as the power. And once we know the power, we know the electrical energy consumed by that very electric appliance in a given time. So let us have there, as we know that electric power is equal to electrical energy consumed. That's what we have learned in the previous video related to electric power there. Electrical energy consumed upon time taken. But we are in need of electric energy consumed. So in other words, or electrical energy consumed is equal to this, gonna multiply over here, is equal to power multiplied by time taken. So that will give you a definition here. In the electric energy consumed, it is denoted by E. You know, power is denoted by P, and the time it is denoted by T. And here it is mathematical expression for electric energy consumed by an electric appliance having power this one and the time this one. So the product of electric power and the time will give you the idea about the electrical energy consumed by an electric appliance. So once you know the electric power of a given electric appliance and the time for which the given electric appliance is supposed to work, will give you the clear-cut idea about the amount of electrical energy consumed by that kind of electric appliance. So the electrical energy consumed by an electric appliance is the product of power rating. This is the power rating because it will give you how much power consumption, rate of power consumption by an electric appliance is called power rating. power rating of that very electric appliance and the time for which the electric appliance is gonna be used there, that give you electrical energy consumption. So that's the definition of electric energy consumed by an electric appliance, which is defined as the product of the power rating of an electric appliance and the time for which that electric appliance is put to use or put to work. So that's the definition. Now we are going to come across the unit. So you are well familiar with the fact that is, yes, the unit of energy or electrical energy is going to be joule. The SI unit, it's going to be joule. Here it is, it's joule. And the power, you know very well, it's watt. And the time, yes, it is second. Or we can write it as J is equal to W and S. And if you want to find out 1 joule electrical energy consumed, then what you are going to do here, 1 joule is equal to, yes, 1 joule is equal to, this is watt, 1 watt multiplied by 1 second. Here it is. Let us just define 1 joule electrical energy consumed by an electric appliance. So very simple definition. We are going to stitch these things together so that we can create a definition. The electrical energy, listen carefully and watch over here. The electrical energy consumed by an electric appliance is said to be 1 joule. The electrical energy consumed by an electric appliance is said to be 1 joule. Then an electric appliance of 1 watt power is used for 1 second. So when an electric appliance of 1 watt power is used for 1 second, then the electrical energy consumed by that kind of electric appliance is said to be 1 joule. So that's the electrical energy consumption, the definition of 1 joule. But remember, this very unit, that is joule, is a very smaller unit of electrical energy, but we use electrical energy on a larger scale. So for the business purposes, we do use, or commercial purposes, we do use commercial unit of electrical energy. And the commercial unit of electrical energy is kilowatt hours. That's the commercial unit of electrical energy. It is kilowatt hours. So let me take the commercial unit here. Commercial unit of electrical energy is kilowatt hour, and it is being written as kWh. Kilowatt hours, or simply it is also known as unit. So kilowatt hours or unit, this is also a unit for the electrical energy consumed. And now we are gonna just create a kind of a definition for 1 kilowatt hour. But remember, firstly we are gonna do this one. That is, unit of electrical energy is kilowatt hour. There it is, kilowatt hour, and it is equal to, we are gonna break it up. You know, this one, here it is, kilowatt. Whose unit is it, by the way? It is a bigger unit of electric power. Because smaller unit of electric power is watt, bigger unit is kilowatt. So we will write it as kilowatt multiplied by, and this is the second factor, or this is the unit for time. It would be written as time. Here it is. This is power, 1 kilowatt. Time, this is 1 hour or hour. And electrical energy, it is kilowatt hour. Here it is. So the kilowatt hours can be written as kilowatt multiplied by hour, or 1 kilowatt hours is equal to 1 kilowatt multiplied by 1 hour. Now we are going to define 1 kilowatt hour. What is 1 kilowatt hour unit? Or simply, it is also known as unit. It is also known as unit. Remember, a state government decide the rate for 1 unit there in a given state. So it varies from state to state. So what we are going to pay as an electric bill, it is under the, you can say, that is the rating of 1 unit being decided already by the state government there. So here it is, 1 kilowatt hour is equal to 1 kilowatt multiplied by 1 hour. So now we are going to define 1 kilowatt hour energy consumed by an electric appliance. What does it mean? So the electrical energy consumed by an electric appliance is said to be 1 kilowatt hour, then an electric appliance of 1 kilowatt power is used for 1 hour. Means when an electric appliance of 1 kilowatt power, you know this is power, then an electric appliance of 1 kilowatt power is used for 1 hour, then obviously when it is put to use it will consume electrical energy. But when 1 kilowatt power electric appliance is used for 1 hour, then the electrical energy consumed by that kind of electrical appliance is said to be 1 kilowatt hour. So that is 1 kilowatt hours electrical energy consumed by an electric appliance is said to be 1 kilowatt hour, then an electric appliance of 1 kilowatt power is put to use for 1 hour. So that's the, you can say that is the commercial unit for electrical energy, or 1 kilowatt hours. What is 1 kilowatt hours? It can be asked in 1 mark category questions in board examination. That is, what is the commercial unit of electrical energy? Yes, what is 1 kilowatt hour electrical energy? These things can be asked. So these are very easy to just digest. Just go through these kind of videos and you will have a clear-cut idea about these terms over there. So here we are gonna just finish with one more thing by taking one more thing here, that is a relationship. If you are listening me very clearly, then I have mentioned the unit of electrical energy is joule. Earlier I have spoken about joule. Now it's kilowatt hours. So it shows that there is a perceptible relationship between kilowatt hours and joule. And as far as the board examinations are concerned, sometimes it is asked, that is, what is the relationship existing between kilowatt hours and joule? And in other way, how much joules are present in 1 kilowatt hour? So that can be done, and can be done mathematically. Let us do that here. Relationship between kilowatt hours and joule, since both are the units of electrical energy. So let us create it here. And you know, kilowatt hour is equal to, yes, we are gonna break it because it is composed of two things. One is power and another is time. Okay, and we will write it as kilowatt multiplied by hour. Here it is. Yes, kilowatt. Here, since kilowatt hours can be written as kilowatt multiplied by hour, or 1 kilowatt hour is equal to 1. We are going to use 1 kilowatt multiplied by 1 hour, or 1 kilowatt hour. You know, since 1 kilowatt is equal to 1000 watt, we have learnt before. So we are going to use here 1000 watt multiplied by 1 hour is equal to 3600 second. Here it is, 3600 second, or 1 kilowatt hour is equal to, one more thing you know, we have learnt before, watt is equal to joule upon second. Watt is equal to joule upon second. So in place of watt, we are going to write joule upon second multiplied by 3600 second. Second cancel, or 1 kilowatt hour is equal to, here it is 36. Yes, 36 multiplied by 3 zeros are available here, 2 zeros are here, and it would be written as 10 raised to the 5, and we are left only with joule. Here it is, joule. So that's the relationship we have got it. 1 kilowatt hour is equal to 36 into 10 raised to the 5 joule. But in some cases, 1 kilowatt hours can be written as 3.6 into 10 raised to the 6 joule here, and that can be done just by a simple mathematical operation here. Yes, that is what the 1 kilowatt hours contains, this much of joules there. Or we can write it as 1 kilowatt hours is equal to 36 into 10 raised to the 5 multiplied by 10 and divided by 10. We can do it. We can apply this very operation. The same number is a multiplier, the same number is a divisor. So there is no basic difference gonna happen over here. And it's joule. And you know 36 upon 10 will become 3.6. And we can write it as 1 kilowatt hour is equal to, yes, it is 3.6 multiplied by, and you know 10 raised to 5 multiplied by 10 raised to 1 is equal to 10 raised to 6 joule. And that's the another, you can say, expression for 1 kilowatt hour. So 1 kilowatt hour is containing 36 into 10 raised to 5 joule, or 1 kilowatt hour is having 3.6 into 10 raised to 6 joule. That's all about electrical energy here. That's it.